Today I want to talk to you guys about data science and design and where they start to come together. And for me, that is at the confluence of machine and product. So we hear a lot today about artificial intelligence, machine learning, deep learning. These are all exciting things. But as we start to move into this sort of near and uncertain future, and as change really starts to accelerate at an exponential pace, the ability for us to deliver value to our customers using model-based or algorithm-based products is becoming increasingly more important. So we play in a space where experimentation is cheap, right? We're able to iterate quickly and learn quickly, and this is starting to accelerate. Our ability to forecast, to predict, and to recommend with accuracy is something that we're becoming better and better at. And we're starting to be able to rely not just on the data to inform our decisions, but to build models based on this data to help us better understand what it is that our customers and users really value. And through doing that, we're able to know our customers better and deliver to them bespoke experiences and transformative sort of services. So as a product person, this is something that is really exciting to me. But the question really is, how do we do that? And the answer is we start to shift away from a data-driven organization and move towards what we're calling a model-driven organization. And this exists with three specific facets. The first one is a product mindset. So this gives us the ability to adapt quickly, to recognize opportunities as they come, and then to seize upon those opportunities. Having robust data, so knowing that our data is comprehensive, that it's unbiased, that it's high quality, and that it is substantial in quantity. And then finally, an ability for us to manage our models. That is to start to build models in a way that is iterative and reusable in nature. So we'll start with talking about a product mindset. This is something that should be pervasive within your organization. And it's kind of broken down into six pieces here. So I talk about it as having a tenacious customer focus, right? The ability to always ask what it is that our customers want. To have a deep passion for what it is we're building and why. So to really attach ourselves to the problem, to love the problem, and to be able to understand that we're building something to attack that problem. The ability to champion experimentation, agility, and iteration. The concept of being outcome-focused and not output-focused, and to really drive towards results. To be collaborative and cross-functional, so to really break down those sort of silos between design, technology, product, and business. And then finally, to nurture a culture and environment where we can aggressively pursue continuous innovation, and to do that through servant leadership. Now, in a model-driven organization, data is the lifeblood. Models need data to operate. They take raw data and turn it into something that helps us make decisions. Artificial intelligence is really just prediction machines that are driven by data. So what we have most available to us are typically proprietary historical data around consumer and user behavior. But if that's all we're using, it's kind of insufficient when we're talking about artificial intelligence and machine learning. If you're not looking for insights from outside sources, you're really only getting half of the story. Historical data is great for training and building your AI, but in order for you to not make the same mistakes of the past, you need to be constantly looking for new and ongoing streams. And then finally, experiential data is something sort of new, which allows us to look not just what our users have done in the past, but what their experiences were like while doing it. And this helps us to kind of round out the conversation and really zero in on what matters to our users. Now, at the core of a model-driven organization is the understanding that the basic unit, the basic building block, is the model itself. And this is what all AI is built off of. Now, most organizations today try to manage models like they would any other business asset. They fall into the thinking that because models involve code and data, they should be treated like any other software asset or any other data asset. But the reality is that models are fundamentally different. They use different materials, they're built in research-based approaches, and they behave differently when they're deployed. So in the same way that we've had to rethink the way that we manage and build software versus hardware, we should now be open to different ways of thinking around how we develop models versus software versus hardware. This is an example of how this comes out in delivery a little bit. So in trying to figure out how we bring teams closer together when we're delivering a product, we're constantly having the conversation about how do we take software development and bring it closer to data engineering and bring that closer to data science. This is a high-level flow diagram around the life cycle of a model of science. And you can see that it's kind of the long pole in the tent. There are a lot of steps that happen here. This brings in a unique challenge for us when we're talking about science and scientists in general, of shifting the mindset from something that is very academic in nature to something that is much more product-focused in nature. Typically today, we see that there are activities within ideation, delivery, and monitoring around problem identification, value alignment, documentation, and value generation that require more focus when we're talking about iterative software delivery. So it makes sense for us to constantly be looking for ways to consistently and safely develop, validate, deliver, and monitor the models that really give us a competitive advantage. This is still a very sort of nascent space, so there's not a lot of standardization, but in general, there are 5 pillars that we kind of look at when we're talking about model management. So technology, the infrastructure that allows us to build and deploy models; development, the ways of working that exist for us to create those models; production, taking a cool idea and making it into something real; governance, that's our ability to kind of monitor the models that we have at play; and then context, which is really a very important piece around knowledge management that allows us to build in a reusable manner. Now, part and parcel to this sort of model management is the idea that there's a certain level of responsibility that exists for us as developers and decision makers. There are too many people who believe that AI is the silver bullet that will solve everything, and we need to start to educate to have business stakeholders, decision makers, and developers start to think critically about when is the right time for us to actually be using artificial intelligence and data science. And more importantly, to understand that they play a key role and have a level of accountability in creating responsible models and algorithms. So AI is fundamentally biased in the way that it's trained, in the way that it's programmed, in the way that it's developed. And so it's important that as decision makers and developers, we have a certain degree of data science literacy. We're always looking to understand the data and the assumptions that we're making with the data. We're able to challenge the models, beat up the models, massage the models, make them work. And then ultimately, we're able to take the outputs from that data science and use those to help us better understand in a continuous manner what the data is and make sure that it's as robust as possible. There's a lot of pitfalls when we talk about taking something that is probably more suited for discussion and debate and boiling it up into a mathematical problem. When we build machines to think like humans, we have to be aware of these biases that we create and try to avoid them. So just a quick example of what this looks like is that humans typically, when we try to problem solve, we use shortcuts that we call heuristics. And when we think about artificial intelligence being teaching computers to think like humans, we give those same biases, those same sort of fallacies to the artificial intelligence that we have as humans as well. So as we advance our own thinking around algorithms, it's important to be aware of and ideally avoid the biases that we create. So in thinking about how we do that and trying to distill the most fair approach to data practices, there are several values that we try to uphold. Each of these speak to empowering the user to be more knowledgeable and to own and control their own data. Each mandates that we treat data like the people it represents, and that we think about the outcomes from our models and what stakeholders would care about that. Perhaps what's most interesting to me about data science and the promise of products being delivered in model-driven organizations is that they have the potential to help us transcend technology and really reach human insights. So while machines will be able to do some of the things for us, that allows us as humans to be able to focus on what matters. There are human traits that are difficult to automate and replicate and digitize, things like emotions and intuition and creativity, empathy, ethics. These all become more and more valuable as we move into this world. Our ability to discover new opportunities and to deliver quality experience is really what we start to index on in the future. In the end, what we're really talking about here is changing mindsets, shifting the way we work in order to start to fulfill the promises of big data. It's in these times that I really want to challenge us to be mindful and informed in the way that we deliver, and to continuously advocate for the data representing the people we serve and for the models which serve them. Thank you.